What if the universe has a memory? I mean, a literal memory. Today, we're diving into a pretty wild new idea called coherence gravity. It's a theory that suggests the past is literally shaping our present, and it might just solve some of the biggest puzzles in all of physics.
So let's just kick things off with a huge question, one that's going to frame this whole conversation. What if the biggest mysteries in the cosmos, the things we've labeled dark matter and dark energy, aren't actually missing? What if we've just been looking at the rulebook for space-time completely wrong?
Because let's be honest, our current understanding of the universe, what's called the standard model of cosmology, it has some huge, glaring holes in it. So let's take a quick look at what I'm calling the universe's dark problems.
Okay, so this is what cosmologists tell us the universe is made of. Now look at that tiny little 5% sliver. That's everything we can see and touch and understand. Every star, every galaxy, you, me, this screen, all of it is just 5%. The other 95%, it's a total mystery, split between two things we can't see or detect, dark matter and dark energy.
So, here's problem number one. When we look out at other galaxies, we see that the stars on the outer edges are whipping around way too fast. I mean, they're moving so quickly they should just be flung off into deep space. The only reason we have to explain this is to imagine a giant, invisible halo of dark matter that's providing all the extra gravity needed to hold the galaxy together.
And then things get even weirder. We've known for a long time that the universe is expanding. But then, in the late 90s, we found out that the expansion is actually speeding up. It's accelerating. To explain that, we had to invent this mysterious anti-gravity force called dark energy that's somehow pushing the entire universe apart.
And finally, there's the problem at the heart of every single black hole. According to Einstein's equations, right at the center, there's a point with zero size but infinite density, a singularity. This is basically where our physics just throws its hands up and breaks down. It's a huge red flag that we're missing something fundamental.
Okay, so 3 massive problems. But what if there's a single, elegant idea that could solve all of them at once? This is where coherence gravity enters the picture. It says space-time isn't an empty stage. It's a dynamic fluid that, get this, actually remembers what happened in its past.
The first big concept here is the coherence field. The best way to think about it is like the water in an ocean. It's the fundamental substance that allows everything else, all the particles and forces, to even exist and have a stable structure. According to this theory, it's the very stuff reality is made of.
And this is where it gets really mind-bending. The theory introduces something it calls a memory kernel. The idea is that space-time has a form of memory. So past events, like, say, the formation of a massive galaxy, they create a kind of lasting gravitational echo. The past state of space-time is literally influencing its shape right now.
Now don't worry about the letters in this equation. Just focus on the idea. On the left, you've got the total amount of gravity, and on the right, it's split into 2 pieces. The first part is the gravity from all the normal stuff we can see. But that second part, that's the new bit. That's the gravity coming from space-time's memory. So gravity isn't just about what's here now, it's also about what's been here before.
So, okay, a universe with memory. That's a pretty radical idea. How does this one concept possibly help us with those huge, dark problems we talked about? Well, this is where the theory gets really, really cool.
Could it be that dark matter and dark energy aren't 2 different mysteries at all? What if they're just 2 sides of the same coin? Coherence gravity says yes. It suggests that this memory halo is what we've been calling dark matter, and the large-scale effect of that same memory is what we've been calling dark energy. One single cause creating 2 very different effects.
Let's break down how that works. On the scale of a single galaxy, the memory of that galaxy's dense core creates a persistent gravitational echo, a halo. This halo provides the extra gravity that makes those outer stars spin so fast. It perfectly mimics dark matter, but without needing a single new particle. But then, when you zoom all the way out to the cosmic scale, the collective memory of all the matter in the universe creates this gentle negative pressure that pushes space-time apart, driving that cosmic acceleration. It's the exact same mechanism, just acting differently on different scales.
So it seems to tackle dark matter and dark energy in one go. But what about that third problem? You know, the impossible infinities lurking at the center of black holes.
Well, coherence gravity has a beautiful solution here too. Instead of matter collapsing down into an infinitely dense mathematical point, it forms a stable soliton core. You can think of it as a super dense but totally finite and stable object made from the coherence field itself. It replaces the mathematical impossibility of a singularity with actual, real physics. So when you put it all together, what you have here isn't just a clever idea. It's a comprehensive, new map of reality. And crucially, it's one that makes concrete, testable predictions. If this is right, it doesn't just tweak our understanding of the universe, it rewrites it from the ground up.
And this is the most important part, right? This isn't just philosophy. It is a testable scientific theory. It makes very specific predictions. It predicts the exact shape of a galaxy's spin. It predicts that dark energy isn't some constant, but that it actually changes over time. It even suggests we might see strange new effects in gravitational waves. These are all things we can actually go out and look for with our telescopes and detectors.
To quote the authors behind this idea, their whole goal is to provide a, quote, coherent alternative to both dark matter particles and the cosmological constant. In other words, this one single framework could potentially replace two of the biggest, most mysterious pillars of modern science.
And all of this leaves us with a final, really profound thought. This theory completely reframes our picture of reality. It suggests that the cosmos isn't just a static stage where things happen, but an active participant with a memory of its own history. So, I'll just leave you with this to chew on. Is the universe not just a place, but a memory?